Good morning and happy Monday or Tuesday whenever you are watching this. So today we are going to go through just some brief points that are extremely important in regards to section 3.3. So we're going to start off on page 71 because we're going to start with some note taking and just making sure we have the key vocabulary terms down. So I'm going to write down two different things, and I want you to try and see if you notice any difference between the two different things. Right away when I look at those, I see the actual equation portion, so that 3x plus 2, that's the same. That didn't change. But if I look at what's on the other side of the equal sign, I notice it's different. But I'm here to tell you that these two things are exactly the same. And I'm sure many of you are like, no way, those are different. They're written differently, so there's no way that they could actually be the same. I apologize for any squeaking that occurs in the background. My dog is playing with her toy. So the way that this is written, the y equals 3x plus 2, that is standard notation. So that is stuff, that is what we've seen before. So this is standard notation. That shouldn't be new. We've seen y equals whatever the equation is. But when we see it with the f of x, that's definitely a little bit different. So the f of x, this is function notation. And I'm here to tell you it really does not change a thing. It's just another way of writing it. And later on, you're going to see that the function notation is handy when we're plugging in something for that x value. So the definition for function notation is another name for y denoted as f of x. And it is read as the value of f at x. So that just basically means like we're solving the equation for whatever x is equal to, that's what the f is going to be. So if you need a pause here, you can definitely do so, get this written down, and then I'm going to go ahead and we're going to move into actually some of the notes. So going up to page 69. So the essential question for today, how can you use function notation to represent a function? It says match each function with its graph. So right away, you can see that all four of these equations are written in that function notation, except now they just use different letters in front instead of the F. That's totally okay. That's just to help distinguish an equation from a different one. So right away, when looking at these equations, I see that two of them have exponents and two of them don't. So C and D have exponents and A and B do not. So when I see ones without exponents, that means it's a linear equation. So that means it's going to make a straight line. So linear, linear. So right away, I can go down to my graphs and I see that I have four graphs below. On those four graphs, only two of them are straight lines. And so now I have to figure out which one goes with which. Right away, I see one that is going up and one that is going down. Well, if you correlate up with positive, that would be correct, and down with negative. Well, when we look at our two equations, we can see that A is positive, B is negative. Therefore, graph B goes with A and graph D goes with B. So this one is A and this one is B. So now we've done half the work. Now we got to look at the next two. So right away, we know the next two is going to be one of these two parabolas. Parabola is just a nice fancy word for making that U shape of a graph. So that's a quadratic function. That's when we have the exponent. Now, really, there's not much difference. Like, okay, they're both facing up, one's skinnier than the other, but really we can't tell that much. But the biggest distinguishing factor is where that graph is touching on our y-axis. So on A, it's touching at -1. On C, it's touching at -3. Well, do you think you can find where those go with what equation? Well, this one has a -1. This one has a -3. It's not by coincidence. So C goes with A and D goes with C. So there you have it. Those are the 4 graphs with the 4 equations. This part we're not really stressing a whole lot, but it is definitely important to be able to look at a graph and see what it could go with. So knowing that if it makes a straight line, it's linear, that means the equation doesn't have exponents. If it makes that U or parabola shape, that means it's going to be something with a power of 2. And so now we're going to consider the function f of x equals -x plus 3. Locate the points x and f of x on the graph. So remember, when they do this, this is just saying this is y. So essentially, we're looking for y. They're telling us, okay, plug in that -1 value for x and tell me what you get. And so we really actually don't even have to do the math on this one. We just have to find the x value on our graph and then locate the y value. So here's my x value right here. Draw that a little bit better. And so I can see, okay, it's going to go right there. And so if I count up 1, 2, 3, and 4, that means it's going to be -1, 4. And if you're like, I still don't trust that. Okay, plug in the -1 to the equation. So I have -1 plus 3. 2 negatives make a positive, so this becomes 1 plus 3, which gives me 4. And that's in fact what we found. So we know we're good to go. All right, let's do the next one together. So we are right on 0. If I can draw right on 0, that would be helpful. All righty, so right on 0, we can see we run in at 1, 2, and 3. So it's 0, 3. Again, plug it into the equation if you don't trust it. Well, -0 is 0, and 0 plus 3 gives me 3. Go ahead, pause here and see if you can do C and D on your own. All right, if you're just tuning back in, it is 1, 2 and 2, 1. All right, so this is the big point we're trying to get across here. How can you use function notation to represent a function? How are standard and function notation similar? How are they different? So the big thing is the thing that makes them the same is it's representing the same equation. The difference is the way that they write y. Those are the two things that are different. But other than that, they're basically the same thing. It's just a more, if you want to say fancier way to write it, sure, it's definitely a fancier way. But in the end, it is the exact same thing. So go ahead and check out Mr. Patinsky's video for some of those extra practice problems. And that's all we have.